Morning. So we are again, meeting with an interesting session today. So last class, when we looked at current electricity. So current electricity chapter, pathina plays a major role, in Neet exam in the chapter, and then you have wave optics, ray optics. So in the chapter, when the amount of questions that come is also the volume of questions that come is also quite high in the chapters. அதே மாதிரி grade 11ல பாத்தீங்கன்னா laws of motion, உங்க thermodynamics, solid fluid mechanics. So இதெல்லாமே வந்து these chapters play a major role. So அதனால we will let's not go very fast. So இந்த chaptersல வந்து நம்ம கொஞ்சம் நிறுத்தி நிதானமா எல்லா questionsமே நம்ம will cover up. So அதுதான் வந்து I have planned off for today. So we'll look at current electricity, and if time permits, we are also going to do the next chapter, that is magnetic effects of current. So moving charges and magnetism is also quite important. So adu nama paathidalam. Okay. So this is what I have planned off for today. So I hope you guys are ready. Shall we?
Yes, sir.
Yes, great. Okay. So here comes the questions from current electricity. We'll see the continuation of questions. Last class la வந்து கொஞ்சம் concepts நான் introduce பண்ணியிருந்தேன். So the base பண்ணி we have questions. Okay. Here comes the chapter name, and let's start off with putting today's date. Today is 5th of Feb. First questions I'm just mentioning here. Okay, here comes a question, quite interesting. Yeah, each of the resistors have been put now. Each of the resistors shown in the given network, each of the resistors shown in the given network is equal to R ohms, basically. The equivalent resistance between terminals x and y is, so I'll give you the network. So this is the question. I'm giving you the circuit for this question. Or network கொடுத்திருக்காங்க. So let me draw that. So this is our network. This is X and this is Y. Okay, na? Let's name the figure also. Let's take this as A, B, C, and in the point we will call it as D. Okay. So this is the figure. So each and every resistor or value is R, capital R. Okay. So if you want, you can intuitively mention there. எல்லாமே R தான். So you will have to calculate what is the resistance across XY. Okay, here comes the options. Option A, R. Option B, 5R. Option C, 3R. And option D, 6R. Yes, try பண்ணுங்க. Yes. So idea வந்துருச்சுங்களா எப்படி பண்றது அப்படின்னு இந்த question, finding out equivalent resistance. Series and parallel combination you can apply for, but for that first you will have to redraw the circuit. இந்த question வந்து circuit வந்து first redraw பண்ணிக்கோங்க. So what are you getting when you redraw the circuit? Anybody?
Sir, 3R வந்து series circuitல இருக்கு sir.
Okay. இந்த XY இருக்கு இல்லைங்களா, ஸோ அதை வந்து யூ கேன் ட்ரா இட் அவுட்வர்ட்ஸ். இதை வந்து நம்ம இந்த பக்கம் லிஃப்ட் பண்ணிக்கலாம். தட் இஸ் அ ஃபர்ஸ்ட் ஸ்டெப். ஸோ வென் யூ லிஃப்டட் தட் சைடு, இந்த சர்க்யூட் வந்து எப்படி நம்ம சிம்பிளிஃபை பண்ணிக்கலாம் நெக்ஸ்ட் ஸ்டேஜ்க்கு? ஸோ யூ வில் கெட் இட் லைக் திஸ். ஸோ திஸ் இஸ் த பாயிண்ட் D and this is as usual X. So I am redrawing the circuit. So the circuit looks like this if I'm going to redraw. இப்படி வந்துரும். Centerல you have one more resistance. ஓகேங்களா? And you have, this is A and this is B. அதுக்கப்புறம் again you have two resistors like this. And this is going to be R Y. This is going to be our Y. So this is point C. So in the மாதிரி you can redraw it. புரிஞ்சுதுங்களா? Same circuit தான். When I open it and redraw, this is how the circuit looks. Okay, so when you go for redrawing it. So who can tell me what the circuit looks like after redrawing? So the circuit after redrawing looks similar to which circuit?
Series.
Series circuit, are you sure? It looks similar to a Wheatstone circuit. ஓகேங்களா? Wheatstone bridge அப்படின்னு சொல்லி ஒரு சர்க்யூட் நான் வந்து இன்ட்ரடியூஸ் பண்ணியிருந்தேன் லாஸ்ட் கிளாஸ்ல. ஓகே, so this circuit looks very similar to a Wheatstone bridge circuit. So that is how it looks. Wheatstone bridge circuit எப்படி இருக்கும்? இதே மாதிரி தான் இருக்கும். நடுவில் இருக்கிற R வந்து அந்த இடத்துல வந்து you will have a galvanometer. So here you have a galvanometer. This is called the galvanometer. One second. So this looks like a galvanometer resistance. So Wheatstone circuit oda main principle pathina, under balanced condition no current will flow through galvanometer, isn't it? So Ig will be equal to 0. If current is 0, obviously the potential drop is also going to be 0. It is as good as you are neglecting that resistance in the center. So adha vandu neenga eliminate panniralam. So that's technically not there for a Wheatstone circuit. So when you redraw the circuit further, how is it going to get simplified? It will look like this. So in the Mari, you are simplifying this in stages by analyzing the circuit. Okay, this is what happens. So XY, again, resistance R, and these four resistors remain. So on the nodes A and B would disappear. You cannot call them as nodes anymore because the minimum eligibility criteria to call a point as a node is three or more components, circuit components should meet. Only if two components meet, நம்ம அதை வந்து node கூப்பிட முடியாது. You cannot call it as a node. Okay, so that is the reason nodes A and B would disappear. So you're only left with nodes D and C rather. So D is there and C is there. That's it. There is no nodes A and B are not there anymore. So now you can apply your series and parallel combinations. Okay, so the two resistors R and R, what combination they are in?
series, sir.
Yes, they are in series. So further நம்ம எப்படி எழுதிக்கலாம்? You can redraw them with a single resistance. And what would be the value of that resistance after you apply the series combination? Yes, what is the value of that single resistance now? Series நம்ம apply பண்றோம். What will be the value? R plus R is going to be 2R.
2R.
Same way கீழே கூட R plus R 2R. So இப்போ இந்த 2R and 2R what combination they are in?
Parallel, sir.
Very good, they are in parallel combination. So final answer would be, what is the final answer? Parallel combination apply பண்ணுங்க. When two resistors are in series, you can find out the parallel resistance using a direct shortcut formula. Do you remember?
R, sir.
This class I taught you. R1 R2 upon R1 plus R2. Direct நீங்க இதை apply பண்ணலாம். So what is
R, sir.
2R into 2R upon 2R plus 2R is 4R. How much you get? 2R into 2R வந்து 4R square upon 4R. So what is happening? 4 is getting cancelled off and your final answer is R ohms. Okay, so the answer is R ohms in this case. So option A is correct. புரிஞ்சுதுங்களா how to approach this question?
Yes, sir.
Yes. So these questions are very, very important. Now identifying whether a given circuit is a Wheatstone circuit or not, and that is very, very important. That is the most important aspect. Now how do you identify really when you have a circuit like this? How did we come to a conclusion that this is a Wheatstone circuit? First one is by redrawing. நம்ம அதை redraw பண்றோம், அதுக்கப்புறம் we are finding out. Okay, there is one more aspect to this. Whenever you find two nodes across each resistor, now look at this given circuit. Each and every resistor has got two nodes across it. See, every resistor has got two nodes. So whenever a resistor has got two nodes or two junctions across it, no doubt that circuit is going to be a Wheatstone circuit. Okay, so therefore you can understand that this is a Wheatstone circuit. So your next step has to be, you should be that you will have to find out which is the galvanometer resistance. Once you identify it's a Wheatstone circuit, next step is find out which is the galvanometer arm, the galvanometer resistance, and then eliminate it and then go for a simplification. So that is how we approach this type of questions. Okay, we'll move on to the next question. The second question for the day. So here comes the second question. See, I'll give you another model for practice. You can try this as well. The effective resistance between points P and Q. Between points P and Q of the electrical circuit is, so here comes the question. So this is the point P. Now I'm drawing the circuit. So I'm giving you the values as well. This is 2R. Circuit is not yet done. So you have another point also. So this is the circuit. So options are option A, 2 times capital times small r upon capital plus small r. Option B, 8 times capital R the whole times r plus small r upon 3r plus small r. And option C, 2 times small r plus 4 times capital R. And option D, 5 by 2 times capital R plus twice small r. Okay, so these are the options. Yes, please try this question. First, draw பண்ணிக்கோங்க. You just draw this question in your notebook. You try it simplifying on your own. Make it a simplified circuit, and then get me the answer. Yes. So what is the approach? என்ன பண்ணலாம் நம்ம இங்க? Yes. Yes, students. How do you solve this question? What is the approach to solve this question according to you? Same model only. Previous question இதுவும் based on the same principle. So how do you understand which of the resistances needs to be eliminated? Any idea? See, okay, I suppose there's no idea, so I'll show you. So same in the circuit la pathina, the same way, the same approach only. Okay, so each and every resistor has got two nodes. Inge or node irukku. Let's call this as D and E. Okay, P and Q da. So adha D and E kuda kooptukkalam. So each and every resistor has got two nodes. You can find that. So whenever you have a circuit like this, first check if each and every resistor has got two nodes across it. Yes, each and every resistor has got two nodes. That means this circuit is a Wheatstone bridge circuit. It's a combination of two Wheatstone bridges, not one. You have two of them. Okay, so you have two Wheatstone combinations. So if you see here, Mela, you have one Wheatstone where this 2R is going to look like your galvanometer resistance. Same way at the bottom also you have one more Wheatstone wherein that 2R ohms, the resistor, looks like the galvanometer resistance. So it's two Wheatstone circuits combined together. So you can eliminate these 2R resistances. So if you eliminate them, how does a circuit look? So So I'm writing it here, eliminating 2R resistors as they represent galvanometer in a Wheatstone. So I'm eliminating that 2R. Okay, so once you eliminate that, further the circuit is going to get simplified. So you will have resistors like this. So this is P and this is Q. And what are the resistors values? This is 2R, these two are R, and then 2R again, capital R. So these are the resistor values. So further, how can we simplify this? Now I think from here it should be easy. So இப்போ நீங்க simplify பண்ணலாம். The most critical part is to identify the Wheatstone in the given circuit, and then after once you have identified that, it's going to be a cakewalk. Okay. So next, இது நம்ம எப்படி simplify பண்ணலாம்? So how are the circuit resistances here? These two. Now look at the combinations and appropriately simplify them. அவ்வளவுதான். It's not a big deal. It's quite simple. So what do you do next?
Add பண்ணனும் சார்.
ஆமா, add பண்ணி சொல்லுங்க. So once you add, you will get 3 resistors like this. So what are the values?
4R, 2R, 4R, sir.
Okay, 4R, 2R, and 4R. Yes. So how next? What combination they are in? Four R, 2R, and 4R. மூணுமே எந்த காம்பினேஷன்ல இருக்கு? Yes.
Parallel, sir.
Very good. Parallel, what do you do? Formula. Parallel formula apply பண்ணுங்க.
1 by R1 plus 1 by R2 plus 1
Yes.
by R3.
Plus 1 upon 2R. So further you simplify this. So 2 times 1 upon 4R is there. So 2 upon 4R எழுதிக்கலாம் plus 1 upon 2R. So what is the LCM?
4 by 4R, sir.
Yes. What's your LCM here?
4R, sir.
4R. Capital R or small r? You have both, no? Capital R irukku plus small r also is there. You can simplify this if you want. So 1 by 2R plus 1 by 2 times small r. Okay. So now what is your LCM once you've simplified it?
2 capital R small r, sir.
Yes, 2 capital R small r, and in the
R plus small r plus capital R, sir.
yes, small r plus capital R. Very good. So இப்போ நமக்கு we just wanted the resistance in resistance value, RP value da. So go for a reciprocal. So finally you will get 2 times capital R upon small r upon small r plus capital R. So this is the final answer that you have. Okay, yeah. So this is what we have. So which is the correct option?
Option A, sir.
Yes, option A is correct. Okay, simple. So this is how you do this type of questions. So this model question, we do it like this. Okay. Yeah. Next, moving on to the next circuit. Next question. Here comes the third question. Okay. The heat generated, the heat generated in the 5 ohms resistor heat generated in the 5 ohms resistor when a current of when a current flows at the rate when the current flows at the rate of 10 amperes per second is 10 amperes per second is so giving you the circuit first. Okay, let me just reframe it. The heat generated in the 5 ohms resistor when the current flows. Change பண்ணிக்கலாம். I'll just rephrase the sentence. When current flows, when current flowing அப்படின்னு வச்சுக்கலாம். When current flowing in it is 10 calories per second அப்படி போட்டுக்கலாம் because we are referring to heat. So 10 calories per second. We will change it like this. Yeah, now going to the circuit. So values of resistors are either one, this is 4 ohms, 6 ohms, and you have 5 ohms. Okay. So options. The heat generated in 4 ohms resistor is heat generated in 4 ohm resistor is options. Option A 1 calorie per second. Option B 2 calories per second. Option C 3 calories per second. And option D 4 calories per second. Yes, இது try பண்ணுங்க. So you need to apply the formula for heat. Okay, heat or the general formulas பாத்தீங்கன்னா I'll just give you here. Heat can be written as a product of power into time. So you get VIT, I square RT, and V square upon R into T. These are all the possible formulas for power. In terms of, for heat in terms of power. Okay, so we express the formula for heat. VIT, I square RT, and V square upon R into T. So just look at the combination and then you can easily find out the values. Yes. So how do you approach this? Any idea? Using the relationship?
சார்
Ah.
ஐ வந்து கொடுத்துருக்காங்க சார் 10 calorie per second.
Hmm.
ஆரும் கொடுத்துருக்காங்க சார் 5 ohm.
10 calories per second. Okay.
Resistance
அது 10
5
calories
ohm.
per second வந்து that is not I. Amperes அப்படின்னு கொடுத்திருந்தா I தான். பட் இங்க வந்து calories per second அப்படின்னு கொடுத்திருக்காங்கல்ல. So it is not I. It is basically the power that they have given. ஓகேங்களா? So they have given actually the power in terms. So here they have given you the power P as, so I think that is where you got confused. So it's power that is being given 10 calories per second. That's your power which has been mentioned in the question. Okay. So the standard unit for the heat one day is not going to be calories. So calories per second கொடுத்திருக்காங்க. So you convert that in terms of joules per second. So how do you go for a conversion? It's quite simple. You just need to multiply with 4.2. So 1 calorie is 4.2 joules then. So just multiply பண்ண வேண்டியதுதான். So 4.2 into 10. So it gets converted to joules per second.
42 joules per second.
Yeah, which is nothing but 42. Correct. 42 joules per second. So you go for a conversion. Once you've gone for a conversion, now you can see that in the question வந்து resistance வந்து 4 and 6 series ல இருக்கு, but it is in parallel with 5. Okay. So you need to first find out the potential difference or the potential across x and y. நம்ம first அது கண்டுபிடிக்கணும். Okay. So the formula that relates potential difference வந்து you can see there are two formulas. This is one and this is one more formula. Okay. So we can use one of them. So we will use the second formula where P is equal to V square by R. So time nama வந்து anyways 1 second தான். So we are not considering that now. So P is equal to V square upon R. Use பண்ணிக்கலாம். Okay. So what is V? Go for a rearrangement. You can get that V square is equal to P into R. So this implies V is equal to square root of
PR.
Yeah, P into R. So in the relation use பண்ணலாம். P வந்து நமக்கு ஏற்கனவே क्वेश्चनல தெரியும் 42 அப்படினு. So substitute பண்ணிருங்க. That is 42. And R வந்து அவங்க क्वेश्चनல வந்து they are specifying that as 5 ohms resistor. அதுக்கு தானே 10 calories. So 5 ohms அப்படினு substitute பண்ணிக்கிறோம். So 42 into 5. இது simplify பண்ணனும். So how much is 42 into 5?
210 sir.
210. Yes. So under root of 210 volts. அதை அப்படியே வச்சுக்கலாம். Let's not extract it from the root. Keep it like that only. So that is the value of the potential difference. So potential difference across xy is equal to under root of 210 volts. So this much we have the information with us. We have found out. Next, now we will find out what is the current passing through the 4 ohm resistance. Heat கொடுத்திருக்காங்க. They are asking the heat, but we need to find out the current as well for the heat. Yeah, without that it would be difficult. So what is the current through 4 ohm resistance? So we will find that. So current passing through 4 ohms resistor கண்டுபிடிச்சுக்கலாம். So how do we find out that one? Here in this question, the 4 ohm resistance, 6 ohm, both are basically in series combination only. Okay. So how can we find out the current? Very simple. Using Ohm's law itself, you can find Ohm's law ல இருந்து நமக்கு தெரியும் V is equal to I into R. Yeah. What is I? Rearrange. V upon R. V நம்ம இப்பதான் கண்டுபிடிச்சிருக்கோம். V ஓட வேல்யூ பாத்தீங்கன்னா is root of 210. Resistance வந்து there are two resistors. You have both 4 and 6, isn't it? So you need to put 4 plus 6 because they are in series combination. So under root of 210 upon 4 plus 6 is basically 10. Okay. So that many amperes. So root of 210 upon 10 amperes. So that is the current. Okay. Next, heat produced. Now we can calculate heat produced in 4 ohm resistor. So what is the formula for heat?
I square RT, sir.
Correct. So I square R into T use பண்ணிக்கலாம் directly. I square அதாவது root 210 upon 10 the whole square into R. What is the R value?
4 ohms, sir.
4 ohms. Correct. Into time T. Just 1
That's
second.
seconds.
1 second. 1 தான். Simplify பண்ணுங்க. So what do you get?
210 by 100 into 4.
Into 4. Yes. Which is yeah, cancel out பண்ணிடுங்க. And remember, this is the values for joules per second தான் நம்ம வச்சிருக்கோம். So this in the our conversion. So and options பார்த்தீங்கன்னா calories-ல இருக்கு. Okay. So from joules to calories now you will have to again divide by that 4.2. So அது மட்டும் ஞாபகம் வச்சுக்கணும். That's it. Okay. So 0 0 you cancel off. Finally what do you get? 21 upon 10 into 40 upon 42. So just go for a simplification.
21 1 times, 42 2 times, sir.
Okay.
10 and 40 cancel out, sir. 4.
Okay. 2 ones are 2 twos are. Are you getting 2?
Yes, sir.
Yes. So 2 calories per second. Okay. So option. So the correct option is
B.
yeah, option B. 2 calories per second. So this is how you will do this question. This is quite simple. So once you know how to approach, things would be at ease. So in the மாதிரி தான் நம்ம solve பண்ணனும் இந்த question. We move on to the next model. Is it clear this question?
Yes, sir.
Yes. Okay. So conversion from calories to joules, joules to calories. So that you need to keep it in mind. Check. So we'll move on to the next model. Okay. So moving on to the next model. In the following meter bridge circuit, if AC corresponding, if AC corresponds to null deflection, if AC corresponds to null deflection of galvanometer is X, determine the value of the radius of the wire of the wire AB is doubled. So when AB is double, what is going to be the radius? Determine the value of radius of the wire AB is double. So the double panona, what is the radius? So here comes the circuit. So this is R1 and this is R2. And here they have given you the galvanometer. So in the galvanometer connect பண்ணிருக்காங்க and it is pointing out to a point. இது வந்து jockey அப்படின்னு சொல்லுவாங்க. The arrow mark is called a jockey. So that is where you touch the meter wire on the meter bridge. So this is point A and this is point B. AB is of 1 meter length. That's the reason it's called as a meter bridge. And this point is C. So this is AC, balancing length. So that is given as X in this question. Okay, that is a balancing length X. So we are asking what would be the value of radius when AB is doubled. So when it is doubled, what is the radius is the question. I'll give you the options meanwhile. Option A is X. Option B is X upon 4. Option C is 4X. And option D is 2X. These are the options. Yeah. So what do you feel is going to be the answer for this? So திரும்பியுமே இங்க பாத்தீங்கன்னா AC வந்து X, so that is a balancing length. So Wheatstone bridge circuits வந்து very I mean meter bridge circuits and Wheatstone bridge circuits go hand in hand. ரெண்டுமே same தான். So the way you represent, I mean the comparisons are different. In Wheatstone circuit you are comparing 4 sets of resistors, that is 2 to each. Here also you are going for a comparison, but you are comparing resistors along with the length. Length தான் நம்ம compare பண்றோமே ஒழிய it is basically the same concept. So இங்க பாத்தீங்கன்னா for R1 resistance you can see the balancing point is the balancing length is X. So what will be CB? I told you total it is
100 minus X. Sir.
Correct, 100 minus X. So நம்ம இதுக்கு equation எழுத போனோம் அப்படின்னா we will write this as R1 upon X should be equal to
R2 by 100 minus X.
அப்படிதான் நம்ம equation எழுதுவோம். Same in the circuit பாத்தீங்கன்னா, so in the galvanometer வந்து if you are going to represent in the middle, it will look like a Wheatstone only. It represents a Wheatstone rather. So ரெண்டுமே ஒரே analogy தான். So in the question என்ன கேட்டிருக்காங்க, they have told if AC corresponds to deflection of galvanometer is X, then the value of radius of the wire AB being doubled. So if you're going to double it, how is it really going to affect is a question. Is the balancing point going to change? Will it be x plus something, or is it going to be less than x? Is there going to be a change in the balancing point of the meter bridge? Will there be any change? The ratio, is the ratio going to get affected if AB is going to be doubled? 100 பதிலா நம்ம 200 எடுத்துக்கிறோம் அவ்வளவுதான். And the x point is going to be remained as x, so you will get 200 minus x. The ratio, is it going to change? R1 by R2 ratio same then அது change
Yes, sir. No, sir.
No, isn't it? So what is going to be the answer? What will be the radius of the wire? It will be x itself. That is not going to change. Same thing. It's going to be same as what it is before. There is not going to be any change. Okay. So the answer is option A itself. So the balancing length would remain unaffected. When the length remains unaffected, now where is the radius going to change? It's not going to change. The length is going to be the same. Okay. So here it is the same thing. So value remains constant. Okay, even though you go for changing the AB length twice than what it is before. Okay, simple. So that's how you conclude this question. So we'll move on to the next part. So we have done, questions pertaining to meter bridge and all these things. Wheatstone bridge questions also we have seen. We have looked at. So now we are moving on to the next questions. So this is done. Heat also we have looked at, a question on heat and heat dissipation. அதுவும் பார்த்திருக்கோம். Kirchhoff's current law and voltage law application based questions also we saw in the last class. If you can remember or recall, அதுவும் நம்ம கவர் பண்ணிட்டோம். So we are almost covering, all different aspects of this chapter. So just a small portion is, left. That is current, number of electrons, drift velocity. So under part matter we will see, and then we will proceed to the next chapter. So we will see those type of questions pertaining to the different parameters of the electrical circuits. I'm bringing in questions from that area. Okay. So before we go to that next part, give you the basic formulas. So Ohm's law formula, I think you know. Same way, resistance formula. So we will have a quick recap of important formulas. So for the numericals which we require, the first one is the Ohm's law relationship. Quite simple. Already you are aware about that. So Ohm's law formula pathina is V is equal to product of current, resistance. Second one, factors affecting the resistance of a conductor, length and area of cross section with resistivity. அது ஒரு formula இருக்கு. So R is equal to rho into L upon A. This is one more formula. And then you have the formula for resistivity, same formula rearrangement. So where rho is equal to RA upon L. And then you have formula for conductance. So conductance also there is a formula. So it's given by the letter G. So it's the reciprocal of resistance, 1 upon R. So that is conductance. Fifth formula, Expressing current in terms of charge and time. So I is equal to Q upon T. That's the formula. Current density, which is given by the letter J. So current flowing per unit area. So it's I
I by
upon,
A.
yeah, I upon A. I by A அப்படின்னு சொல்லலாம். So this is one more relationship. Okay. And yeah, so these are the things. So drift velocity formula also is necessary. I think I gave drift velocity also. Do you remember the formula for drift velocity? There are relationships. Next, the seventh
Minus
problem. சொல்லுங்க.
minus E tau by M
Yes.
into E.
Yes. So that is in terms of acceleration, we can write it as A into tau, okay, which can also be written as minus E times electric field into tau upon M, okay, where T is nothing but the relaxation time of electrons. Okay. Same drift velocity in terms of current can also be expressed. So you have I is equal to E,
NEVD.
yeah, NEAVD. This is also one more relationship. Adhe mari in terms of current density also can be expressed. J is equal to NE times VD. You go for a rearrangement, you will get this. So these are all the important formulas that you should be knowing. Okay. So based on this, we have questions. Now we will start with the questions based on all these 9 formulas which we have. So we will move on to the questions now based on these. Okay, we look at simple questions and then we'll move on to the different complicated ones. So here comes the question. The drift speed of electrons in a copper wire, the drift speed of electrons in a copper wire having resistance, okay, having resistance 10 ohms and area of cross section and area of cross section 1 millimeter square, when a potential of 10 volt is applied, when a potential of 10 volt is applied across it, is options. Option A, 0.658 millimeters per second. Option B, 0.078 millimeters per second. Option C, 0.75 millimeters per second. and option D 0.065 millimeters per second. These are the options. Okay, and you assume, small assumption based on the given question, assume number of electrons per cubic meter number of electrons per cubic meter in copper is 8 into 10 to the power of 28 electrons. Yes, so this is the question. The question in a given data, so write all the given data, appropriately use the formula and come for a conclusion. Okay, simplify panni, you can tell me what is the value that you get. Yes, try this. So they have given you the resistance R, they have given, area of cross section is given, potential is also given, potential difference is also there. So which formula can we use here? Any idea? Drift velocity I gave some formulas. So in the formulas use panna the question solve pandrathu. Which one would be more apt? You can see that there are 3 formulas pertaining to drift velocity. The 7th one, here also you have a drift velocity term. So out of these 3, which one would you use? Which would be a perfect fit? 7, 8 or 9?
8, sir.
8th formula. Yes, you can go for using 8th formula because you have information about the parameters. Correct. I is equal to En.
Area irukku sir adula.
Correct, area irukku. So adanal it is more apt. Yeah. So use it and simplify it. So I is equal to ENA VD. So but current we don't have. We get a current illiye. How you have potential and you have resistance. So how can we remodel this or reframe it? You can write current in terms of Ohm's law, isn't it? You can do that. So I is equal to V by RL. So you can go for a rearrangement. I mean, you can express current in terms of potential and resistance. So simply you can write V by R is equal to ENA VD. So you wanted VD now. Keep VD on one side, shift all other terms to the other side. So what do you get when you do the shifting? VD is equal to V upon ENAR. This is what you get. Substitute the values. V is 10. What is the value of E? Charge of an electron.
1.6 into 10 power minus 19.
Minus 19. Correct. Number of electrons also is given in the question. 8 into 10 power 28. Area is 1 millimeter square and resistance is also 10. Now simplify all this. 10 10 will get cancelled. Fully you have to simplify this and get me the answer. 10 power minus 19 mela kondu ponga becomes 10 power plus 19. 10 power 28 you take it up. 10 power minus 28 upon 1.6 can be written as 16 upon 10. ஸோ அந்த 10 கூட மேலே கொண்டு வந்துடலாம் into 8. சரியா? So now you simplify this.
10 power minus 8, sir. By
16 into 8, if you multiply, how much you're getting?
128, sir.
Okay. 10 power minus 8 upon 128. Now 1 by 128 in decimals you have to express. So this is already in millimeters per second only now. The units are millimeters per second. So 1 by 128 in decimals. How much are you getting? Yeah, divide பண்றீங்களா? Decimal places ல சொல்லுங்க. 1 by 128. How much you're getting upon dividing?
007, sir.
0,
7.
We need at least two decimal, one more value. Significant figures, we need one more. After 7, what comes?
8,
0
sir.
point you would get.
0,
No?
0.0078, sir.
0.0078. Correct. Okay, so we'll get it like this. Into 10 to the power minus 8. Okay. Now how can you further simplify this?
Seven point eight into 10 power minus 5,
7
sir. Delta.
7.8 into
10 power minus 11, sir.
into 10 power minus 11. Okay. So 7.8 into 10 power minus 11. So here 0.078 is what is close, isn't it? So if you go by the options of the elimination method, so you can see that 0.078 is close. So answer is option B, most close value. That's what we have. Okay. So here you have to be careful with the conversions. So conversions you need to take care and appropriately go for a simplification. Okay. So that is what you need to do. Okay. So that is the aspect. So electron charge correcta we substituted. Number of electrons also you substitute, and appropriately you go for a simplification. Now, area of cross section also, appropriately you find out. Okay. So 1 millimeter square they are told. So appropriately, 1 millimeter square also appropriately you simplify. So when you simplify that, you will get the answer accordingly. Okay. So 0.078 is what is most approximate value that you get. So answer is option B. So 1 millimeter square also expressed in terms of meter square. Now you know that it is going to be 10 power minus 6. So that minus 6 is what is a factor that's you're getting a difference. So minus 6 plus 6 iron. So minus 8 plus 6, I think you're getting the answer. So it would be minus 2. Okay. So in that case, you would not get this 10 power minus 11. So what I mean to say is that area of cross section we didn't substitute. This is 10 power minus 6 then. So that also will come. Okay. So when you bring it up, it will become 10 power plus 6. So minus 11 plus 6, you know that it is going to be negative 5. Isn't it? So you shift the decimal places. So appropriately, you will get the value 0.078 into 10 power minus 3 meters per second. So in the minus 3 da the milli. So 0.078 millimeters per second. அதுதான் அவங்க அப்படி எழுதியிருக்காங்க. Okay. So this is how you do the conversion. Is it clear?
Yes, sir.
Yeah. So here I'm including that 10 power minus 6 also. Simple. So that is the value. So answer is option B for this question. Okay. Moving on to the next one. We look at the next model also. This question 5. Moving on to the next model 6. So next sixth question. So based on drift also we have seen now. Next we have temperature coefficient of resistance. Based on that we have some questions. Okay, the temperature coefficient, of resistance for resistance wire அப்படின்னு வச்சுக்கலாம். For resistance wire is 0.00125 degrees Celsius inverse. Okay, or per degree Celsius. So that's the reason I'm putting degree Celsius inverse. At 300 Kelvin, its resistance is 1 ohms. At what temperature, or let's rephrase it, the temperature at which the temperature at which the resistance increases by unity is the temperature at which the resistance increases by unity is options A 1227 Kelvin, option B 1127 Kelvin, option C 1327 Kelvin, and option D 1117 Kelvin. Okay, so these are the options. Temperature coefficient of resistance concept is being used. The formula for temperature coefficient of resistance one day vidha. So R of T is equal to R naught plus 1 plus alpha T. Okay, where alpha is a coefficient of temperature. I mean coefficient of the coefficient of resistance அப்படின்னு சொல்றோம் இல்லையா? That is what is alpha here. So that is 0.00125. So that is basically your coefficient. Okay. First find out the temperatures. and then you can solve it. Yes, you can substitute and go for a simplification in this case. So question la pathina, they have given you alpha in terms of degree Celsius inverse. They didn't give you in terms of Kelvin inverse. So first you convert everything in terms of degree Celsius so that calculation becomes easy. Okay. So ellame Celsius la vechukonga. So what is the general expression? This is the general formula. The base of which we are going to solve this question. Okay. So 300 Kelvin in Celsius, what is the value? So what will you do for conversion from Kelvin to Celsius? You would add 273 or would you subtract 273?
Subtract, sir.
Subtract, correct. So 300 minus 273. How much is that? 27? Isn't it? So 300 Kelvin is rather equal to 27 degrees Celsius. Correct. So that resistance at 27 degrees Celsius, you can write it as, so other than RT abin potrukkolla, RT is equal to R0 into 1 plus alpha T. And we are applying that. Is equal to R0. R0 is nothing but the initial value of your resistance. Okay. R is equal to R0 into 1 plus alpha into T. So T is 27. So alpha into 27. Okay. So on the value, so that has been found out as 1 ohms. Isn't it? That's the question la kuduthirukanga. At 300 Kelvin, resistance is 1 ohms abin sollirukanga. So this is what we have. Okay. The relationship. Okay. Same thing at a certain temperature. Say at certain temperature T, R0 times 1 plus alpha into T. So at certain temperature, they are saying the resistance is increasing by unity. What do you mean by increasing by unity? By a factor of 1. முன்ன இருந்ததை விட ஒரு 1 ohm அதிகமா இருக்கு. So 1 plus 1 will basically give you 2. So 2 ohms. So we have two equations. We need to solve both the equations. First equation you understand that R0 into 1 plus 27 alpha is equal to 1. From second equation, you get R0 into 1 plus alpha T is equal to 2. These are the two equations that we have. Okay. So now simplify these two equations. You can go for, any method of simplifying. So you can go for division. Isn't it? So divide both the equations. What do you get? Second equation by the first. Do 2 by 1. 2 by 1 panningana, what do you get? You'll get 2 upon 1 is equal to 1 plus alpha T upon 1 plus 27 alpha. So this is what you get. So go for a rearrangement for T. T ku vandu rearrange pannunga. So what do you get? 2 times 1 plus 27 alpha is equal to 1 plus alpha T. So what is T here? When you rearrange T,
2 into 1 plus 27 alpha divided by
27 times 2 is 54, I suppose. Isn't it? Minus 1. The whole divided by alpha. In the mari varum. Yeah. Idu vandu simplify pannunga. 2 minus 1 is anyways 1.
1.
Yeah. So 54 alpha plus 1 divided by alpha is equal to T. So alpha value vandu erkanave question la kuduthirukanga. So you need to substitute here. Okay. So alpha value in the as per the question is this.
0.00125, sir.
Yes, 0.00125. Substitute பண்ணுங்க. Plus 1 divided by 0.001. So this is the value. Go for a simplification. Substitute பண்ணுங்க. Multiply these two values and add with 1 and then divide. Okay.
Manish, அப்படியே ஒரு 2 minutesல wind up பண்ணலாமா?
Wind up பண்ணிடலாம். Okay. Yeah. So this we need to go for a simplification. Just multiply the values. 54 into 0.00125. How much are you getting? I'm getting a simplified fraction. So you convert pannunga. When you convert in terms of exponential form, it's very easy to simplify. You will get 27 upon 400 if you simplify this, plus 1 divided by அதே மாதிரி 0.00125 அதையும் simplify பண்ணுங்க. You will get 1 upon 800. Okay. So go for LCM. What is the LCM?
Is it
400, sir.
LCM is easy, no?
Is it 854?
Yeah, 854 is correct. Uncle is correct. Superb.
மனசுலே போட்டேன்.
So 427 upon 400. So I am showing the steps here one by one.
No problem. Yeah, just
427 upon 400. மேல இருக்குது நீங்க LCM பண்ணீங்கன்னா இது வரும். கீழ வந்து you have 1 upon 800. Then you go for a reciprocal, isn't it? So and obviously you know what happens next.
427 into 2, sir.
427, that is 854, yeah.
Okay, so that is nothing but 854. Okay.
Can I tell one more method on this? For this? குழந்தைகளா?
Yeah, sure.
Just இது கொஞ்சம் இந்த ஸ்க்ரீன் மேலே போங்க. இல்லை போதும். இப்போ இந்த இடத்துல 54 into 0.00125 plus 1 divided by 0.00125 இல்லைங்களா?
ஆமா.
அப்போ ஐ ஆம் டிவைடிங் பை 0.00125 போட்டால் ஃபஸ்ட்டு இது வந்து 54.
கரெக்ட்.
அடுத்தது 1 by 0.00125 is 1 lakh divided by 125.
ஆமா.
That is 800.
Correct.
854. I did it like this.
Okay, கீழ வந்து 1 ஆயிரும்.
ஆமா. அடுத்து 1 by 0.00125 இருக்கு இல்லையா? அது வந்து 1 lakh divided by 125.
Yes.
That is 800.
Correct.
So 800 plus 54, 854.
Yes, perfect.
இல்ல எதுக்கு சொல்றேன்னா இது மாதிரி மனக்கணக்குலயும் போடலாம்னு இருக்கா சும்மா ஒரு மெத்தட், இன்னொரு மெத்தட் அவ்வளவு.
ஆமா. கரெக்ட். நம்ம அப்படிதான் பண்ணுவோம்.
ஆமா.
By nature, by default we do this, but நம்ம பசங்களுக்கு காமிக்கணும்
இந்த மாதிரி எல்லாம் பண்ணணும். இல்ல the students should know many methods.
Correct. So many methods are there. Yeah.
Sir.
So 854 degrees Celsius வந்து you go for a conversion to Kelvin. Okay. So Kelvin நீங்க கன்வர்ட் பண்ணுங்கன்னா I already told you when you go for
273.
ஆமா. So 854 plus 273, you just add it gets converted to Kelvin. So how much is that?
1100.
Yeah,
1027, sir.
இது நீங்க டைரக்டாவே பண்ணலாம். So you will get the answer as 11,127. Correct. That's all. That is the answer. Okay.
Sir.
Yeah.
நீங்க எப்படி சார் இங்க 400 divided by 400 ன்னு சொன்னீங்கல்ல சார், அது எப்படி சார் செய்யறது? 27 divided by 400.
Okay. So அது வந்து exponential calculation தான். See, I did it like this, 54 into 0.00125. நம்ம அதை வந்து so I'm shifting this decimal places and writing in terms of exponent because I like the exponential calculations. So அப்போ நம்ம 125 ன்னு எழுதிக்குவோம். So I'm shifting the decimal places to the right இல்லையா? So into 10 to the power, உங்களுக்கு laws of indices நீங்க apply பண்ணீங்கன்னா you will get it as 10 to the power of
-5.
Yes. -5 வரும். So you take it down, it is nothing but 1 lakh then. So that way, keeping it as exponent, I feel it is comfortable for me. So I do it as a exponential calculation. அதே மாதிரி இதுவும். ஸோ இதுக்கும் நீங்கள் அந்த 10 power minus 5 வந்துடும். ஸோ ஐம் டிவைடிங் அண்ட் ஐம் டிவைடிங் பை 10 power minus 5 on both the sides and then expressing like this. So you will ultimately get this step. So அந்த மாதிரி. So I feel rather than keeping it to decimals, converting to exponents for me it is easy. So I do it that way. அவ்வளோதான். Okay?
Okay, sir.
So here, what is the correct answer? The answer is?
Option B, sir.
Option B. Okay, 1127 Kelvin. That's it. So maths arithmetic simplifications வந்து நம்ம நிறைய approach இருக்கு. நம்ம இதுதான் approach அப்படின்னு சொல்ல முடியாது. So there are different ways of solving. It all depends on, you know, the approach that we are taking. அவ்வளவுதான். That is what matters. Probably we may take a minute or, you know, 2 extra mind calculations. If you're able to do it, you will save that 1 minute or 2 minutes. Avalada, nothing more. Okay, so this is it. So with this we'll wind up. Okay, so I will post the notes also in the group. Fine. Yeah.
Thank you, sir.
Thank you so much, Manish and everybody. உங்களுக்கு ஏதாவது டவுட் இருந்தால் நீங்கள் குரூப்பில் அனுப்புங்க. Don't wait till the last, next class. Okay? Right. Okay, Manish. Thank you.
Okay.
Thank you, sir.
Bye-bye. Yeah, welcome. Bye-bye. Take care.